Hello everyone and welcome to Elementary Experiments Summer Edition. So because we have summer reading going on from June 17th all the way until August 10th, we are doing our videos a little bit differently just because we are all so busy at the library. So in Elementary Experiments we are doing an extra activity, but instead of walking through the activities with you here on screen, I'm just going to be describing them and giving you the instructions. We will still walk through the crafts together. Remember, you can pick up the craft kits at the Manchester City Library if you are in grades 1 through 6 at the children's desk. As before, we will be going with our summer reading weekly themes. We are having Elementary Experiments every other week, so we'll be kind of covering 2 weeks each time. All right, let's see what we have for this week's Elementary Experiments. Welcome to this week's Elementary Experiments, where we are doing old school science, where we are covering our Back in Time and our Water Quest weeks. So our very first activity is to do with this here. So this is a turkey feather. So you're probably aware of a lot of the things people did with turkey feathers. Namely, they were used in writing. You see this a lot in pictures and like films and stuff like that. So you would do calligraphy or cursive writing with a quill pen. Most of the time they were swan or feathers like this one because they are the strongest. But really, you can do it with any pen that have a hollow interior because these pens do rely on capillary action, which we have talked about in past elementary experiments, to hold their ink and then release them as you write on the page. I will warn you that if you guys do attempt this, which I hope you do, it does take quite a bit of practice to write with a quill pen. It is very different than writing with a ballpoint pen or a felt tip pen. And it's also the reason why our cursive writing is formed the way it is, because the way the letters are formed in cursive make it less likely that you are going to make splotches when you write with your quill pen. Also, one last quick fun fact about calligraphy is most of the time, all of this beautiful feather plumage that you see, and we will often see in like pictures and movies about that time period, was actually cut off because when people were writing, they didn't want to keep like hitting themselves in the face as they wrote. So oftentimes they would trim this down and sometimes even cut it shorter. Anyway, if you would like to do your own calligraphy practice, take a look at these directions. Our second activity is our Cartesian diver. We've actually done this before in elementary experiments, but I think it's really cool. It kind of tells you a little bit about density, especially when it comes to water and air. And actually, back in time, this was actually considered a magic trick all by itself. So I don't know if you guys can see, but I will demonstrate in my model. If we squeeze, and our little diver in the middle will go up and down. All right. Again, if you would like to make your own Cartesian diver, I am going to put up the instructions, and I wish you luck. As with most things, it might take a little bit of time to get your proportions correct, but don't give up because it is a fun magic trick even today. Welcome to our craft for our old school science. For this, we are actually going to make and learn a little bit about calculating on abacus. So an abacus is basically what they used in ancient days, and not so ancient days, before they had calculators or even slide rules. So this is basically a way of doing math where you don't have to keep it all in your head and you have like that visual help to look back on. According to our instructions, what we are going to make is a 5-bar abacus. In your kit, if you pick one up from the Manchester City Library, you will have 3 strips of cardboard with 5 holes evenly spaced. You're going to have 5 things of floral wire. You're going to have 2 shorter pieces of cardboard. You're going to have 45 various pony beads. And then what you're going to also need for this is either some hot glue or some tape. I do think that hot glue or a similar type of glue is going to be better for this, especially because we do have like a middle bar in the abacus. But I think that you would be able to use just tape. So I think I might try with tape just to make sure that it will work okay with a little bit of help. So let's get started. All right. So what we're going to do is we are going to end up with the 3 bars with holes, with 2 of them a little bit close together and then one with a little bit more space. And then the short bars on the side, and then we're going to have our wire go through the middle and strung with our beads. I think the best way to do is we are going to start with our basic frame. So I'm going to put one of these longer bars aside, and we are going to put our frame together. So we take our tape. So here we have our base form, and I did put the long pieces on the inside of the short pieces, if that makes sense, so that when we fit in our 3rd bar, it's going to fit in between. All right, so we're going to secure our 3rd bar in between. Remember, we want it closer to one of the sides. The biggest thing is we're going to end up putting 2 beads on that top section. So we want to make sure that there's enough room for those 2 beads to stack and then us be able to move them up and down freely. So once we kind of make sure that there's enough room for that, which there should be plenty, we are going to tape or glue that bar in place. So here we have the outline for our abacus. Now what we're going to do is we're going to take our wire and we're going to take a bead and kind of wrap the wire around it, sort of like this, and then we're going to twist to secure. And if you need, definitely get some pliers or an older person to help, because this wire, even though it's pretty loose, when you're twisting it like real tight, it can get a little bit hard to deal with and a bit sharp. But once you have that through, what we're going to do is we are going to put it through our first hole here, so that it is coming through this space. And then we're going to put 2 beads onto it. Like I said, we're just going to have a random bunch of pony beads. So choose whichever ones you like, or if you have your own beads you would rather use, that's also okay. And then put that wire through the hole in the middle beam. So you can see here, we've got our beads. Then when it's in a large space, you're going to get 5 more beads and put them on, like this here. And then we're going to thread our wire through the last hole down here on the bottom. We're going to pull that, and then we're going to take one more bead, and we are going to put it on the bottom here, and twist the wire around it so that our wire is secure and is not going to come out. All right, and that is going to make our first line of our abacus, and we're going to repeat that for all 5 of our bars. So once we have all of our beads on, your abacus is going to look something like this. If you think about how numbers are written out, you can kind of see how this might work. So we're going to have our ones place, our tens place, our 100s place, 1,000s, and then 10,000s. And how you read from an abacus is basically what is touching this bar is what we are counting. So it's a little hard to show me. Let me do it sideways so I can move the beads. So to start off, we would slide all the beads on the bottom down and all the beads on the top up. And then it's going to be whichever bead we slide up to touch the middle bar is going to be how we count it. So we could do 1, 2, 3, 4, 5. And then once we hit 5, we would slide these down and slide one of the beads from the top over. So this bead here counts as 5, and then we would continue 5, 6, 7, 8, 9, 10. And because we have the 2 beads on top of this type of abacus, we could slide these 2 down, and so these 2 beads touching the bar means it would be 5, 10. So we have 10 in that column, right? And then we would use the other bars the same, but for those different places, right? So we could do this here would mean that is 12. So if I was going to put in this here, what do you think that would be, right? All right, so this one would be 234. Okay, and then for a little bit harder, we could do, there we go. All right, so that number, needs to say, all right, this number here. Okay, so this is going to be 4,000, because we've got 1, 2, 3, 4 in the thousand spot. Here we have 1 bead on this side and 1 bead that keeps trying to escape on this side. So that's 6 in the hundreds. Then we've got 3 on this side. And here we, again, keep trying to escape, but we should have 1 up here and then 4 here. So that means that is 4,639. All right. Finally, let's do a quick bit of arithmetic. So we have to set our abacus to 0, which means all of the beads on top are pushed to the top and all of the beads on the bottom are pushed to the bottom. And so let's try to add 55, which is a 5 in the ones place and a 5 in the tens place, right here. 55, and then let's plus 34, right? So we would do 3 in the tens place and 4 in the ones place, right? So now we can look at our abacus and see how much that is, right? So that would be 8 here and 9 here. So the answer would be 89. All right. And you can do the same thing, but in reverse for subtraction. So you would start with your beads and then take them away. and work your way up to larger numbers because we have 5 rows here, which is quite a bit. That's some big numbers that you can get to. And it is a lot easier when it is flat because the beads are less likely to roll, and you can just move them easily like this. Okay, so that is our abacus for our old school science. This one is actually based on an ancient Chinese version of the abacus, especially with the 2 beads on top and the bar separating the 2. This was developed in China about 3,000-ish years ago. And like I said, it's been used for a very long period of time until we started using things like slide rulers for like even more complicated calculations, and then finally calculators. So I hope that you enjoy making this creation. The tape is okay. It turned out pretty well. I did reinforce tape on both sides, and I think that helped. Again, I think a strong glue, like a hot glue, is going to be sturdier, but you can do it with tape, as I've just proved. So I hope that you enjoyed creating this colorful math tool, as well as learning a little bit about history. That is all for this craft. Thank you so much for joining me for Old School Science. That is all I have for you guys today, other than, of course, my book recommendations, which will be at the end. I do want to remind you that during the summer we are doing elementary experiments every other Tuesday. So we have this one, and then next Tuesday we will be doing something else. So definitely check our calendar for that. It can vary depending on the day, so it's always exciting to look and see. Then the next Tuesday, we will be back here for another elementary experiment where we are going to be piecing it together for our Spy Central and Rugged Exploration weeks. So we are going to be looking at some archaeology and a little bit of coding, spy versions of coding, not computer coding. All right, that's all for today. I will hopefully see you all later. Goodbye.